about reverse bias. Okay, so this is reverse bias, not forward bias. It's reverse bias. Reverse bias. Now, if you turn the DC source around, okay, direct current source around, or you turn this PN junctions, okay, inverse it. So, and then you will reverse bias the diode as shown in the figure. Okay, you reverse the reverse bias. Okay. Now, these times we join or we connect the positive to the N type and the negative to the P type. Okay, so just now forward bias is a positive to the N type, sorry, positive to the P type, negative to the N type, but this time's positive to the N type and negative to the P type. Okay, so this connection is called the reverse bias. Reverse bias. For this one also, okay, you can see that the directions of the currents is in the opposite of the directions of the arrow of the diode. Okay, the arrow diode to the left, but the current to the right. So this is reverse bias. Reverse bias. And for reverse bias, there is no current or very low current flow in the circuit. So you can assume that there's no current. Okay, you can assume that there's no currents. So no currents or very low currents flow in the circuit for reverse bias. See the explanations of why reverse bias, no current flow. Okay, so let's come back to the this is a depletion layer. Okay, so this is the positive terminal, this is a negative terminal. Okay, positive, negative. Okay, something wrong. I think this one is still the forward bias. Okay, the connection is not correct. So let's change this a little bit. Okay, let's make it like this. So this is the negative terminal and this is the positive terminal. Okay, so this is the negative terminal and this is the positive terminal. If we connect positive to the N-type semiconductor and negative to the P-type semiconductor, so the positive terminal, it will pull, just now there's electron here, okay? There's electron here. So this positive terminal, it can pull the electrons here to go to the circuit, okay? And this negative terminal, it can supply electrons and this electron will move into the hole here. And this will result positive charge accumulates at the depletion layer and negative charge accumulate at the P-type semiconductor at the depletion layer. Okay, now just now the depletion layer is only here. Okay, it's only here, and the barrier voltage is 0.3 volt. Okay, 0.3 volt. But if this is, let's say this is 0.8 volt. Okay, 0.8 volt. Then this 0.8 volt, it will pull the electrons to the right. Okay, and the electron will fill the hole. Okay, and this. Okay, then from here you can see that this widens the depletion layer. It makes the depletion layer become wider, right? So it makes the depletion layer become wider. Okay, and at the same time it will increase the barrier voltage from 0.3 to 0.8. Okay, the barrier voltage will increase from 0.3 to 0.8 and the depletion layer will become wider. So the negative battery terminal attracts the hole and the positive battery terminal attracts the free electrons, and because of this, holes and free electrons flow away from the junctions and the depletion layer gets wider and the barrier voltage also increases. And when the barrier voltage increases up to 0.8 volt, okay, and then it will stop there, but then no current flow. No current flow. Or sometimes we learned that in 2 weeks ago. Okay, sometimes there are some free electrons flow out. Okay, free electrons suddenly come out from the semiconductor. Okay, and then these free electrons, sometimes there's some free electrons go here. Sometimes there's some hole. Okay, but it's a minority flow. It's not the majority flow. Okay, it's a minority flow. So it's just a very low currents detected. So that's what happens. Okay, that's what happens. If you draw the graph, let's go back to this one. Okay, so if you draw the graph, you will find that the graph will look something like this. Okay, so it will be a very, very low current around this area. So you connect the reverse bias. Okay, you will find a very, very low currents around this area. Okay, or almost zero. Okay, so this is the reverse bias. Here forward bias. Okay, if the voltage higher than the barrier voltage, then the currents will increase. But for the reverse bias, no. Okay, always or almost no currents flow. Okay, so that's what happens if we connect positive to N-type and negative to P-type. Okay, so this is called reverse bias. You can make the depletion layer become wider. You can make the barrier voltage become higher, but the currents that flow in the circuit still is either zero or very, very low. Okay, for reverse bias.